Today we're going to talk about the mathematics of gerrymandering. Let's begin by considering this population of people who either identify as green or purple. How would you divide this group of 50 people into groups of 10? We have a total of 20 green people and 20 purple. One way to do it is to just go across. And here we have a total of 5 groups. 2 groups are green and 3 groups are purple. But there's other ways of doing this. We can take another group of people and group it this way, and we'll get no green and 5 groups where purple is the dominant winner. In this case, green doesn't have any representation, even though they represent 40% of the people. And yet there's still other ways we can arrange groups. In this case, we can arrange the groups so that green wins 3 groups and purple only wins 2, even though if you look at the individuals, purple has a majority. This manipulation of district boundaries for one party to get an unfair political advantage is known as gerrymandering. In gerrymandering, there are 2 main tactics that are used. The first is called packing, and that's where you concentrate your opponent's voting power in one district to reduce their voting power in other districts. The second is cracking. That's where you dilute the voting power of your opponents over many districts. And here you can see, in order to dilute the power of purple, we packed purple into 2 big groups, and then the other 3 groups, we spread purple out so they weren't the majority. These oddly shaped districts are actually reflected in real life. Here we have congressional districts that are oddly shaped. In order to prevent this, many states do require their districts to be compact, but there's no one mathematical measure of compactness that we can agree upon. So instead, there are a variety of other ways to measure this, such as the perimeter of the boundary, or how close the shape's area is to that of an actual circle, or even the average distance between residents in that district. Now, compactness doesn't completely solve the gerrymandering problem. The efficiency gap is one approach to quantifying the fairness of a voter system. Now, there are 2 kinds of votes that can be wasted. The first is when you vote for a losing candidate, and the second is any vote beyond what's necessary to win for a winning candidate. We then define the efficiency gap is the difference in totals of wasted votes for each party. And we're going to express this as a percentage of total votes. To calculate the efficiency gap, we first look at the purple. Districts 1 through 5, purple lost. So all those votes will count towards the losing. In addition, it only needed 5 votes from districts 6 through 10 to win. So it went 10 votes beyond what was necessary to win. So those were also wasted votes. And same thing for the green. Districts 1 through 5, it won, but it only needed 5 votes. So 10 votes for each of those districts were wasted. And then districts 6 through 10, green lost. So all those votes were also wasted. And so adding this together, we get a total of 0, which gives us an efficiency gap of 0%. This efficiency gap of 0 corresponds to an independent notion of fairness, meaning that the voters across the state are evenly split between both parties. And we can see green won 5 districts and purple won 5 districts, so it was evenly split. Let's take a look at another scenario. What's the efficiency gap here? Again, if we start with purple, purple lost districts 1 through 9, so all those votes are wasted. And District 10, purple only needed 1 vote to win, so it had 18 votes wasted. If we look at green, green lost District 10, so that one vote in District 10 for green was wasted. In District 1 through 9, green won, and they only needed 9 votes to win. So they had a surplus of 2 votes for each of those. Adding this up, we get a total of 80 and an efficiency gap of 40%. This high efficiency gap percentage is clear. You can see that purple was packed into District 10, leading the way for green to win Districts 1 through 9. And let's take a look at one more scenario. We can see that purple lost Districts 1 through 7, so all of those votes were wasted. Purple also won Districts 8 through 10, but they only needed 3, so each of those districts had 14 wasted votes. In green, they won Districts 1 through 7, but they only needed 7 votes, which meant that they had a surplus of 6 votes that were wasted. And then green lost Districts 8 through 10, so those were also wasted votes, giving us a total of 40 out of 200 wasted votes, which comes out to an efficiency gap of 20%. And so in this scenario, green won 7 districts and purple only won 3. All 3 scenarios we considered had the same number of votes for green and the same number of votes for purple, but we had 3 different outcomes. And we also saw that we had 3 different efficiency gaps. And so tools like the efficiency gap can identify when districts are fair and help prevent gerrymandering. And finally today, I'll leave you with a puzzle. Can you create districts where purple wins? We're having groups of 5. Pause now if you need more time, because the answer is right here.